Well, hello, welcome. This is Cranston Leo. Can you see Leo? Leo's a big boy. Welcome to Algebra 2. We're going to start a new chapter today. Very exciting. Maybe. This is Algebra 2 with Mrs. Cran's second week online schooling. Ooh, exciting. We're going to start Chapter 8. We are not going to by any means do all of Chapter 8. We're going to do half of it. We're going to simplify rationals. Chapter 8 is all about rational expressions and rational equations. And what is rational? Well, in math, rational is a code word for fractions. Because a rational number is a number that can be written as a fraction. This is a chapter exclusively about everybody's favorite fractions. All right. So every problem is going to have 1, 2, 3, 4, 5 fractions in it. Okay, and we're going to simplify it down. All right, so chapter 8, fractions. And yesterday, I'm hoping you watched the short factoring video because factoring is going to be super important in this chapter. Okay. First, I just want to go through a concept though, fractions. How do you simplify fractions? That's what we're going to be doing. Okay, if I have this fraction here, am I allowed to just like divide out those 3's? Okay. Hopefully you're saying never, no. I cannot just divide out those 3's. I could add the numerator and get 12, and then take 12 divided by 3 and get an answer of 4. Okay. Or I could divide 3 by 3, and that's 1, and then add 9 divided by 3, which is 3, and I could also get 4. Both valid ways to simplify this. Okay. Well, now all of our fractions are going to have variables with x's or x squareds or x cubes or whatever variable we're throwing in there. Okay. So here's what we can never ever do. If you've got like a plus or you've got a minus, you can't just cancel out those x's. Okay. There's nothing I can really do with this. I mean, I could break it up into x over x plus 9 over x, and x divided by x is 1, and 9 divided by x is 9 divided by x, right? But really, I would just leave it. Okay, you cannot simplify that. If these were x squareds instead of x's, all right? Same thing, I cannot just cancel out my x squareds, okay? For the same reason, I can't just cancel out those 3's and say this is 9, okay? Now, when are we going to be able to cancel and simplify rationals? When things are being multiplied, all right? So 9 times 3, multiplying, divided by 3, I am allowed to cancel the 3's. And here I do get 9. Okay? Or I could multiply up top, get 27 divided by 3 and get 9. This, I think, is a better way to get 9. Right? Here, if I replace the 3's with x's, yes, I can cancel the x's because they're being multiplied and I could get 9. Okay? So our goal is going to be things being multiplied so that you can simplify. All right? And that is what's going to lead us to factoring. So here's our first problem. Now, if you have paper, you can work through this problem with me. I think it'd be a good idea. All right, so if you write it down, we're going to simplify this. Now, the directions on these problems are not going to be helpful. All right, simplify. Well, what do I do? All right, the first thing I want you to think of is factor. All right, so we're going to have to factor each problem that has a minus or a plus in it, okay? All right, and we're going to have to factor typically the numerator and the denominator, both, okay? All right, so I have to look at the numerator and say, what kind of factoring is this? Is it a GCF? No. All right, look for that first. Is it a difference of perfect squares? Yes, it is. So I square root and I square root. And the way you factor 64x squared minus 25 is you square root and you get 8x square root minus 5. And same thing with plus 5. That's difference of perfect square. Now I factor the denominator. GCF. What's the greatest common factor? Is it just a 2? Every even number has a 2. I think so. 2. And then you get 16 divided by 2, 8x, minus 10 divided by 2, 5. So what we're going to do on these problems, we're going to factor the top and the bottom typically. Okay. Sometimes you can just factor only the top or the bottom, but here, most of them, we're going to factor both. And then when you get a common factor on the top and the bottom, the common factor will cancel. Now we can simplify. What's my final answer? It equals 8x plus 5 is left on the top, 2 is left in the denominator. Now this is a fine answer. You can leave it like that. Now if you want to break it up, 8x divided by 2, you could say 4x plus 5 divided, I get a fraction. So if I get a fraction when I divide, I just typically do it like that. Okay? So here's your answer. Now, in parentheses, a lot of times it'll say, oh, state restrictions on the variable or variables, x or y, or if there's a z, that kind of thing. And restrictions come from the denominator. The denominator is not allowed to equal. You're never allowed to divide by 0. Okay? So restrictions, here's what we do. We find the zeros of the denominator. Now you can't look at the simplified one. Right? You got to go back to either the original, or I usually just go to the original factored one. And I find the 0. So I say 8x minus 5 is not allowed to equal 0. So I add 5 and divide by 8. 5/8. This is the one restriction. X can't be 5/8 because 16 times 5/8 minus 10 is 0. Okay, so restrictions is going to be a number like 5/8 or -2 or 7/5 or something like that. Okay. First problem done. Second one. Again, simplify. Factor. How do you factor the top? GCF is not just 2, the greatest common factor is 4. And then you're left with x plus 4. Denominators, trinomial. Okay, is there GCF? No. Is there a number in front of the x squared? No. So you just factor 16, so the factors add up to 8. That's 4 and 4. So it factors into x plus 4 and x plus 4. Now I can simplify. If you get the same factor on the top and the bottom, you cancel, and it's always 1 for 1. This x plus 4 cancels with this x plus 4. This one has to stay. All right, so final answer, I have a 4 on the top, x plus 4 on the bottom. Finished. Do not simplify. You can't divide those 4s out because of the plus. All right, final answer. Restrictions on the variables. What can x not be? Well, I have 2 factors in the denominator. They're the same. What are the zeros of the denominator? X plus 4 cannot equal 0. The restriction is x cannot be -4. One restriction. Next one. Numerator. -6 minus 3x. Denominator. Trinomial. Numerator, denominator. Let's just look at the denominator. Doesn't matter which we do first. How do you factor -16 to add up to -6? That'll be -8 and hopefully you're saying +2. So the denominator factors into x minus 8 and x plus 2. Now the numerator just has a GCF. Now, what is the GCF of -6 and -3? Well, I could take out a 3, like here I took out a +2, or I could take out a -3. Which one do I want to take out? Well, it depends on what's left over. If I take a negative 3 out of negative 6, negative divided by negative, I get a positive 2. If I take a negative 3 out of negative 3x, I get a positive x. Do I want to take out a negative 3 or do I want to take out a positive 3? Well, look at the denominator now. Remember, the goal is to simplify. I want to cancel common factors on the top and the bottom. I need the same factor on the top and the bottom to cancel. All right, is 2 plus x the same as x plus 2? Yes, they're the same thing, right? You can switch the order when you add and get the same thing. It's commutative property. So here, these cancel. Right? So here I want to take out a negative 3, so that I get the same factor on the top and the bottom, so I can simplify. I get negative 3 on the top, x minus 8 in the denominator. Final answer. Okay. Now, what are the restrictions? Restrictions come from the denominator, not allowed to be 0. There are 2 factors in the denominator, 2 zeros in the denominator. What are the zeros in the denominator? X cannot be, you add a positive 8, and from x plus 2, subtract 2, negative 2. 2 restrictions. All right. Come from the zeros of the denominator. 4. Numerator is just 4x. If there's no plus, no minus, there's no factoring. I cannot factor the top. Now, how about the denominator? What is the GCF in the denominator? It is 8x. Then I'm left with 16 divided by 8, 2x plus 1. Okay? So now, the denominator is 8x and 2x plus 1. The numerator is 4x. Right? I do not have a binomial to cancel like I have. Right? All I can do is simplify 4x divided by 8x. Right? My x's will cancel. X divided by x cancels. And 4ace becomes 1/2. So now my whole numerator canceled out. So I can't forget to put a 1 on the top in the numerator. In the denominator, 2 and 2x plus 1. Final answer. Okay. 1 over 2 times 2x plus 1. Now you could distribute that 2 back in, but usually I just leave it factored. Okay? There's our simplified answer. All right, again, you could write 1 over 4x plus 2 if you want. That's totally fine. All right, this one's probably better, but both are totally acceptable. All right, now restrictions come from the denominator zeros. There is a 0 from 8x. 8x is not allowed to equal 0. Divide by 8. The first restriction is x cannot be 0. Then from 2x plus 1, you subtract 1 divided by 2. X cannot be negative 1/2. These are restrictions. All right, simplifying. 5. If there's no plus and no minus, like on this problem, there's no factoring. Okay? So what do? We've done problems like this. To simplify, you simply divide your numbers or reduce the fraction. Negative 54 divided by 9, negative 6. Okay? Where does that go? Numerator, because it's not negative 1/6. Now division means you do what with your exponents? Who knows? I know you know. I know most of you know. All of you know. Subtract your exponents. So 3 minus 4, I get negative 1, but no negatives. So x to the positive first goes in the denominator. Lastly, negative 4 minus a negative 7. That's double negative, so add 7. I get positive 3. So why did the third goes up top? So negative 6y cubed over x. Final answer. Okay. Last one, number 6. Then we'll do a little bit more. All right. x minus 8 divided by 8 minus x. Same binomial except the order switched. Are these the same? Does x minus 8 actually equal 8 minus x? No, it does not. Subtraction is not commutative. You can't switch the order and get the same thing. But I can, because there's a minus or a plus, I can factor. But here I am not going to factor the top. But in the denominator, I'm going to take out what they have in common, which isn't much. They have a 1 in common, but they also have a negative 1 in common. So if I take a negative 1 out of positive 8, I get negative 8. And if I take the negative 1 out of negative 1x, I get a positive x. So now look what we have. X minus 8 over negative 1 times negative 8 plus x. Now these are the same. X is positive, 8's are negative. So now these do cancel out, and I get 1 over negative 1, which is negative 1. So these will cancel with a negative 1. Okay. Now, moving on. Same kind of problem, but now we're going to multiply and simplify. So we're going to have more than one fraction, 2 fractions, or even 3. Okay. Multiply and simplify. All right. Multiply and simplify and state restrictions. All right. Well, am I going to multiply? Well, I could multiply straight across. 4 times 14. 8 times 12. Okay. Or I could simplify and then multiply, which is what I'm going to do. When you multiply, you can simplify diagonally or straight up and down. So I'm going to simplify first straight up and down. 4/8. That's 1/2. 2. 14 twelfths. I can divide by 2, right? So I get 7/6. So now I'm left with 7 on the top. 2 times, now I'm actually multiplying 2 times 6, 12 in the denominator. Okay. Now what? Well, just like above here. When you divide, you subtract your exponents. So x to the second divided by x to the third, I get x to the negative 1, so x goes in the denominator positive. Then I do my y exponents, 1 minus 3, I get negative 2, so y squared down there. Finished. Okay. 7 over 12x, y squared. Final answer. Restrictions come from denominator can't be 0. Well, my restrictions are y cubed cannot be 0. All right. Opposite of cube and cube root of 0 is 0. Y cannot be 0. Then from x cubed, x also cannot be 0. 2 restrictions. 0 cubed is 0. 0 cubed is 0. Okay. 2. Back to factoring. If you have a minus or a plus, you're typically going to be factoring. GCF, let's take out of the first numerator a 4 and 8 divided by, you get 2x minus 1. Denominator, GCF, 5. 2x minus 1. Aha, we see something that'll cancel. Now, GCF of 5 and 15, 5, and you get x minus 3. Now, here I could take out GCM of either 3, say I take a 3, I get 3 minus x. Okay. Or, now what did we do when you had the same thing with a minus, but the order was switched? We took out the negative, so I'm going to take out a negative 3. That makes this a negative 3 and that a positive x. Then these will cancel. X's are positive, 3's are negative. And what else cancels? 2x minus 1. You see anything else? All right. 5 divided by 5. The 5's cancel. So I am only left with 4 over negative 3. That is negative 4/3. Final answer. No x's even in that. It can happen. Okay. Lastly, I'm going to do the restrictions. X cannot be from 2x minus 1, positive half. From negative 3 plus x, positive 3. 2 restrictions. 2 numbers that would make the denominator 0. All right, number 3. Oh, we've got 1, 2, 3 fractions. And 1, 2, 3, 4, 5 times. I probably have to factor. You can't factor a 2. So let's start factoring. Just say factor, 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 factor. All right. I need to factor. I can't just cancel out these x squareds of those 2's. I got to factor, 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 factor. All right. GCF. GCF is 5x. And you're left with x plus 3. First numerator factor. GCF here, 10 and x. And you're left with x minus 3. Okay. Times. Now, this has to be factored. I need 2x and x to factor 2 and negative 3 to multiply, add to negative 1. Let's see. So this could be a plus 1 and a minus 3. Yes, negative 3 plus 2, check. All right, how about this last guy? This is 2 and 1. How about negative 9? Probably negative 3 and positive 3. And I want 2 times 3, 6. 1 times negative 3 to multiply, add up to 3. All right, so that's 2x. Goes with the minus 3. And then x plus 3. Good. Factored. Times. On my last fraction in the numerator, I can take out a 2, and I get x minus 3. And then, ooh, there's a 2 down there. Okay. Now, when you're multiplying, right, you can cancel straight up and down, like we did here, or diagonal. Now, can I cancel an x plus 3 and an x minus 3 straight up and down? Never. X plus 3 and x minus 3 will never cancel. I can't factor anything out like a negative 1 and make them cancel, right, like I did here. These will never cancel. Okay? But look diagonal. I got x plus 3 and this x plus 3. Then all the way over here, I've got x minus 3 canceling with x minus 3. Okay? And straight up and down, 2x minus 3. How about this? Straight up and down, 2's cancel. So this last fraction is gone. Middle fraction, x plus 1 on the top. First fraction, what's 5x divided by 10x? X is cancel, and 5 divided by 10 is 1/2. So 2's in the denominator, and x plus 1 in the numerator. Simplifies way down. The 5 gives away, and the 10 becomes a 2. So the only thing left in the denominator was the 2, and in the numerator, x plus 1. Now, if I were to go through all the restrictions on this, x cannot be from 10x, 0, from x minus 3, positive 3, from 2x minus 3, 3/2, and from x plus 3, negative 3. 2 doesn't give me a restriction because it doesn't have a variable. These are all the restrictions. Whew. This is the most important part, though, simplifying. Okay. Last thing we're going to do is opposite of multiply, which is divide. All right. But then you can say, Mrs. Krantz, you don't divide fractions. if I gave you 2/3 and said divide that by 4/9, you'd say there is no division of fractions. You leave the first fraction and times by the reciprocal. And then I would personally cancel. That would give me a 3 on the top. And that would give me a 2, and I'd get 3/2. Okay. This is exactly the process we're going to do here. There's no division. Cross it out and make it a multiply. We're going to times by the reciprocal of only the second fraction. Do the reciprocal of the second fraction. So x plus 1 goes in the denominator. 3x minus 12 goes in the numerator. But remember, we're going to factor almost everything that has a plus or a minus. Now, x plus 1 doesn't factor. But here I can take a 3 out and get x minus 4. Okay. Now, I don't flip the first one. Just flip the second. But factor. Right? Denominator is a difference of perfect squares. Difference and square root, you get x plus 4 and x minus 4. Then in the numerator, you factor negative 15 to add up to 2. That is x plus 5 and minus what? Hopefully you're saying 3. Yep. Then you cancel. You have the same factor on the top and the bottom. And sometimes there's not that much you can cancel. X minus 4s looks like that's all I can do. Right. At least one thing will cancel. Right. Now, how do I write my answer? Well, on the top I have x plus 5, x minus 3, and 3. So write the monomial 3 first, then x plus 5, then x minus 3. Okay. Denominator, I've got x plus 4 and x plus 1. And that's it. Leave your answer just like this. Factored. Okay, don't FOIL it all out. This is the perfect answer. All right, done. Last one. Division problem. We say no division. You multiply by the reciprocal. So flip the second fraction and factor. Now I can't factor 3xy to the 4th, but this is a difference of perfect squares. So square root. Up top now is 2x minus 3 and 2x plus 3. Factor. First numerator, nothing to do. No plus, no minus, no factor, no factoring. Now this guy I've got to factor. 2 and negative 12 to multiply, add to 5. Now what is this going to be? Is this going to be 2 and 6, 1 and 12, 3 and 4? Let's try that. Which one's negative? Negative 3, because I want 8 minus 3 adds up to 5. Okay, so 2x and x. So I've got 2x, and then I'll go with my minus 3, and x plus 4. All right. So do a flimp, factor. Now we cancel, same thing in the top and the bottom. 2x minus 3's cancel. Now, what about this? 6 divided by 3. That becomes 2. So I have, what's this going to equal? 2 on the top, x squared divided by x. Subtract your exponents, 1x on the top. How about the denominator? 1 minus 4y cubed in the denominator. Then 2x plus 3 up top. And x plus 4 denominator. Final answer. All right. Oh, that's the dog. All right, so this is 8-4, simplifying rationals. I'll give you an assignment in the book, and just think factor, cancel. All right, good luck.